Well, dear my students, in this video I will be telling you movement of inertia of different bodies about different axes of rotation. So first of all, here is movement of inertia of thin rod. Thin rod. This is thin rod here. Thickness negligible, length L. So number one is about this axis y dash passing through CM. So number one A about an axis passing through center of mass and normal to length. This axis here is normal to the length. Since it's a rod, so center mass will symmetrically lie at midpoint. So it is I equal to ml square by 12. Please don't get afraid. So many things we have to learn. Keep on revising patiently. You will learn so many things very easily, but you have to learn. And I have seen in different exams, these things are applied in different questions. So please don't get afraid with so many things how to learn. Number two, B part, about an axis through one end. This is about an axis through one end and normal to its length. I could have written all formulas here and asked you to write down. I am deriving so that you may understand easily and you can concentrate. So there is one theorem of parallax I told you. From theorem of parallaxes. Suppose this is y dash y double dash. So this I will be ICM. But the axes are parallel with distance L by 2. ICM plus mh square करता है. mh square h here L by 2 ICM ml square by 12 plus m into l square by 4. When you add it, what you will get? You will get 1 by 3. You will get 1 by 3 ml square. This length L. 1 by 3 ml square. This is an important idea of theorem of parallaxes. Okay. Now number two, moment of inertia of rectangular lamina. rectangular lamina. है भाई, movement of inertia of rectangular lamina. What is that? Rectangular lamina, I will draw little lamina about an axis passing through center. ये लेंथ L है और ये ब्रेथ B. Actually, in one way we can treat it like thin rod along length and breadth, and then it will be I equal to m upon 12 L square plus B square. L square plus B square. है भाई, m upon 12 L square plus B square is the moment of inertia of rectangular lamina. ये angle 90 है बेटा. Here I will angle 90. Actually, to show the axis perpendicular, I have drawn like this, so that you feel that this axis is perpendicular to the surface of the lamina. Now next, moment of inertia of ring. Moment of inertia of ring. There may be two axes, one normal to surface passing to CM. Ring has total mass on the along the circumference. Its radius R. I mean, this is another axis. It is y dash. It is x dash. The moment of inertia of ring, its mass radius R, mass capital M. So number one, about an axis passing through center of ring and normal to the ring. That is here y dash alone. That I have told mr square. Mr square. It is mr square. Now about an axis. About an axis. इसको A लिखो B. About an axis along diameter of ring. Here you can use theorem of perpendicular axis. This is another diameter, this angle 90. So Ix plus Iy equal to Iz. So 2I equal to mr square. भाई इन दोनों का बराबर ही होगा. I और I both along diameter, and sum of moment of inertia about two mutually perpendicular axes lying in the plane of lamina is equal to moment of inertia about third axis is normal to plane of lamina and passing through the point of section. So this I will be here now mr square by 2. So this moment of inertia of ring is about any diameter, this one or this one or this one, koi bhi. All diameters will be lying in the peak. Now, moment of inertia of disk. Moment of inertia of disk. The square of rupees 10, 5, they are like this. They are disk. Actually, disk can be shown here like this. Having uniform mass distribution. Having uniform mass distribution. This is one axis, normal to plane and passing center. This is another along diameter. That will be x dash. It will be y dash. Moment of inertia, I told you, property of body which opposes any change in rotatory motion. But it does not depend only on mass. It will depends on mass and the distance from axis rotation and shape and size. क्या साइज है, क्या शेप है. In case of ring, the whole mass is along. In case of ring, whole mass on the circumference, and here the mass distributed throughout. सारे में mass distribute है यहाँ. So number 1 about an axis normal to plane of disk and passing through center mass. अब passing center is center of disk. In figure it is I y dash. So this will be mr square upon 2. Moment of inertia of disk. Again b about any diameter. About any diameter. Again you can use theorem of perpendicular axis to find out भाई ये भी आई होगा तो ये भी आई होगा, ये mr square by 2 है ही. So that is I equal to mr square upon 4. Using theorem of perpendicular axis you can write like this. This is iz. Whosoever is the diameter, but every diameter lies in the plane. इसके अबाउट भी है, इसके अबाउट भी सेम होगा, इसके अबाउट भी होगा. Moment of inertia of disk about any diameter. Now I come to moment of a hollow cylinder. Hollow cylinder. Hollow cylinder may be of two types. One having thickness negligible. तो पहला हम लेंगे negligible thickness. means the whole mass is in the surface. This is cylinder. It may have axis like this, x dash, y dash. No, y dash. तो अबाउट x dash जो होगा a about its standard axis. X dash that I equal to mr square. Simply y, because a hollow cylinder having that behave like a ring having a certain height. So it is mr square. Number B, about an axis normal to length and passing through CM, central mass, that I will be, it may behave like a thin rod. It may behave like a thin rod. So it will be 1 ml square by 12 if length is L. Length L, radius R. I mean ml square by 12 plus mr square by 2. mr square by 2. You can write here के m common L square by 12 plus r square by 2. Actually, in competitive exam like NEET, like IEEE, they ask this thing is application of ring and disc, है ना भाई, इसके अबाउट सारे रिंग की तरह. ठीक. Now, if the cylinder has hollow cylinder again, having mass distribution of certain thickness, if it is here and it has mass here, this is internal radius R, this is external radius capital R, and mass here, mass यहाँ पर है. Dear friend, never escape from learning. If we are ever learner, then we are successful person. Otherwise, we are not. So it will be, about x dash. Here this is x dash, and this is y dash passing through center. Y dash. So number one, about hollow cylinder ही है, hollow cylinder, but thickness is there. So about x dash, I is equal to, it is here, half m by 2 into r square plus r square about xx dash. Now about y dash is an L, sorry, about y dash. I is equal to m L square upon 12 plus I is equal to m bracket L square upon 12 plus r square plus small r square upon 4. Yes, 4. Actually, in school teaching, what is the problem? Time given to teacher is small, but facts syllabus is large. And in competitive exam, they ask the question lying on boundary. Now, sphere, moment of inertia of sphere, about a diameter, moment of inertia of sphere about any diameter. About any diameter, that I equal to 2 upon 5 mr square. And now if the sphere is hollow, having some thickness like this, that has internal and outer. They are internal are mass dm. Then again about n diameter, moment of inertia of hollow sphere. About any diameter. This is 2 upon 5 m bracket r square to the power 5, small r square to the power 5 upon r cube minus small r cube. And last here is moment of inertia of cell, spherical cell. Like this, only mass here only, about any diameter. About any diameter. I equal to 2 by 3 mr square. The mass is only on the circumference, surface, hollow, spherical cell. So these are some moment of inertia which you have to keep in brain and keep on learning. Video has become little lengthy, but don't bother, it will help you.